Okay, just confirm. Am I audible to you?
Sir, screen is not visible.
No, I have not written anything. Can you see now?
Yes, it's visible.
All right.
Yes, sir.
All right. All right. So
Yes, sir,
let's.
visible.
All right. Let's continue the discussion in complex numbers. Yesterday we learned about the magnitude, the modulus. Sorry, magnitude or modulus both are same. Then conjugate and argument of a complex number. In argument, we also studied about the principal argument. Okay, its interval lies between minus pi to pi. There is some working rule by the help of which we find principal argument, right? So, based on two concepts, that is modulus and principal argument, we are going to study a new form of complex number, a new way of representing a complex number, which is called the polar form. So, let us try to understand what is the polar form of a complex number. We already know we already know that z equals a plus iota b is any complex number. Is any complex number. And we have to express it in a polar form. Now, what is the meaning of polar form? We will see. Listen carefully. We have discussed it so many times that complex number is actually a point in Argand plane, right? So this is Argand plane. We have real axis and imaginary axis cutting each other at origin. And in this plane, there is a point a comma b, which is actually the complex number a plus iota b. All right. Then, if you remember, yesterday only we discussed these things. That distance of this point p or the complex number, whatever you say, its distance from origin is nothing but mod z. If you remember, mod z is the distance of the complex number from the origin, right? Then the line segment joining this complex number and origin with the positive real axis, right? This angle, since here we can understand with the help of first quadrant, we can also say it is the principal argument. Okay, or you just forget about it. Just try to understand one thing, that distance of p from origin is mod z. This is the definition of modulus. And theta, it is the angle which the line segment joining complex number in origin makes with positive real axis. Okay, these two things. Now what we are going to do, we are going to drop a perpendicular. We are going to drop a perpendicular from p to this real axis. Let's say this point is m. Now all of you are familiar with plotting a point. So if this point is a comma b, then OM should be equal to a and PM should be equal to b. That is why the coordinates are a comma b. Now we will use some simple trigonometry here, and in this triangle POM, which is a right angle triangle, if we use cos theta, this is base upon hypotenuse. This is base upon hypotenuse. This is a by mod z cos theta. And if we want to find sine theta, this is perpendicular by hypotenuse. So this is b is equal to mod z sine theta. So with the help of trigonometry in this right angle triangle, we have calculated values of a and b. Now what we will do, in the standard form or the general form of complex number, we will put these values of a and b. So in place of a, it will be mod z cos theta. In place of b, it will be mod z sine theta. All right. What I have done, in place of a and b, I have substituted these values. Now I will take mod z common, and this is it. This form, where z is written as mod z into cos theta plus iota sine theta. This is the polar form of complex number. So in order to write polar form of complex number, you need two things. Mod z, which is modulus of complex number, and next one is theta. Theta is the principal argument. Theta is the principal argument of complex number. And we already know how to calculate these two. So from the given complex number, you will have knowledge of A and B. With the help of A and B, you will find mod z and theta, and you will put those values of mod z and theta here, and that will be the polar form of complex number. So any form where complex number is expressed in terms of its modulus and principal argument, it is called the polar form. Remember this. And what is a plus iota b then? A plus iota b is the general form. It is some particular form, polar form, where theta and mod z are used. Okay. Generally, we express complex number as a plus iota b. But if someone says that express this complex number in its polar form, then you have to use mod z and theta. Let us try to use this and try to solve some questions based on this. There is a complete exercise in NCRT which is based on expressing the complex number in polar form. Let us solve few questions on it. Right. Following. And so you need two things, mod z and theta. Mod z is simple. It is under root a square plus b square. Remember, which is principal argument here. And for principal argument, we had the discussion in the last class that first we will write the complex number in general form. Then we'll find some acute angle alpha by the help of formula tan alpha is mod b by a. And then based on the position of the point or the position of the complex number that it is present in which quadrant, we have four types of principal argument. Either it is equal to alpha, or pi minus alpha, or minus alpha plus pi, or minus alpha. So today again we are going to use those concepts in the questions. So write following complex numbers. Write following complex numbers in polar form. So I will solve the first question for you. Then next 2-3 questions you will be solving from your side. So first, z equals 1 minus root 3 iota. Let us start with this one. Okay. Now you have the values of a and b because you can compare it with the general form. Okay. And based on that, you have to find mod z and theta. Let us start by finding mod z first. Here, a is 1 and b is minus root 3 theta because I am comparing this complex number with z equals a plus iota b. Now we have a and b, therefore we can find mod z. Okay, first step is to find mod z, and the formula is under root a square plus b square. This comes out to be root 4, which is 2. Then let us find tan alpha. Tan alpha is mod b by a, mod b by a, that is root 3. From here we will find the acute angle, which is 60 degree or pi by 3 radian. Now z equals 1 minus root 3 iota, which is actually a point 1 comma minus root 3. 1 comma minus root 3, it is in which quadrant? Real, positive, imaginary, negative. I think it is in fourth quadrant. Real, positive, yeah, fourth quadrant. It is like x positive, y negative, right? Fourth quadrant. And if you remember from the previous class, that principal argument in fourth quadrant is equal to minus alpha. Okay. Principal argument is minus alpha, and this comes out to be minus pi by 3. So you have value of mod z, you have value of principal argument, and now see this formula in the box. Z is mod z into cos theta plus iota sin theta. So how you are going to write and where you will leave it? Z equals mod z to cos of the angle, which is minus pi by 3, plus iota sine of minus pi by 3. This is the final answer. Do not solve it further. Do not solve it further. Now do not put any values of cos or sine, otherwise it will change back to the standard form. You will leave it here as it is. 2 represents mod z, then the bracket it is cos theta plus iota sine theta, and what is there in place of theta? Principal argument. which you have already calculated. This is minus pi by 3. You will leave the answer here and that will be it. Okay. We have expressed the same complex number 1 minus root 3 iota in the complex in the polar form, which is 2 into cos of minus pi by 3 plus iota sine minus pi by 3. Okay. Leave it here. So this is what you have to do in such type of questions. Okay. Now I'm going to give a similar question. Let us see.
Excuse me, sir.
Yes.
So why it's for the principal argument, so why it's equal to minus alpha?
It is in fourth quadrant, no? Yesterday we had the discussion that first we'll find tan alpha, okay, mod b by a. There we will find the acute angle. In first quadrant, principal argument is alpha only. In second, it is pi minus alpha. In third, it is minus alpha plus pi. And in fourth, it is minus alpha, right? And why it is so? Because principal argument is considered from minus pi to pi. That is why. Okay. So fourth quadrant angle will be a negative angle, clockwise angle. That is why. All right. Is it clear to you? Anyone having any other doubt?
So that is Z is equal to mod of Z or just Z
No, it is 2.
in
No,
the
it is
final
not Z.
answer?
It is 2. It is 2. 2 is mod Z. In place of
Okay.
mod Z, I have got the
Okay.
value 2 that I have substituted here. Okay. Why I will write Z is
Okay.
equal to Z? It will make no sense. Okay. What I am doing?
Sorry, sir.
No, it's okay. You should be clear. See, I have calculated mod Z. I have calculated alpha and sorry, principal argument. And after that, what I have done? I have substituted their values here. Okay, that's it. Nothing else. Let us solve more questions that will help you uh, understand in a better way. The second question. I want all of you to try this. Change it in the polar form. Let me write the values. All right. This is the question. Change it in polar form, and if anyone solves it, then he and she can speak up. Any one of you. Minus 1 plus iota. Change it in polar form. What is mod Z for this question? What is mod Z?
So root 2.
Yes, root 2. So first part is over. Mod Z is under root of a square plus b square. This comes out to be root 2. Now we'll find tan alpha. Tan alpha is b by a. Mod of b by a. B by a. That is 1. Find the acute angle alpha from here, which is pi by 4. Now, can anyone tell me what will be the principal argument? It is in which quadrant?
So 3 pi by 4.
Yes, correct. 3 pi by 4. Why? Because answer will be pi minus alpha or 3 pi by 4. Because Z, which is actually a point minus 1 comma 1, is in second quadrant. And in second quadrant, argument is pi minus alpha. So finally, Z is mod Z cos 3 pi by 4 plus iota sine 3 pi by 4. Alright, it is very simple. Find mod Z, find principal argument, put there in the formula, that's it. And both of you already know, we had a discussion about these things yesterday only. Okay, polar form. Now question can be asked in the reverse order, which is very easy. They will be giving you the complex number in polar form, and they will be asking you to write in the standard form. It will be the easiest question. Why? Because you will be just needing to put the values of trigonometric ratios. Like for example, write z equals root 3 cos pi by 6 plus iota sine pi by 6 in standard form or general form. They can ask in any way. Okay, in a standard form or general form. Because see, from the appearance only you can understand. Is it so?
Yes, sir.
What can you see?
It's not
Sir,
frozen,
not
sir.
visible.
So it's just lagging little bit.
Can you
Okay,
show the
so
previous question?
wait a minute. Can you see this question now?
Yes, sir.
Z equals root 3 cos pi by 6 plus iota sine pi by 6. This is the question. You have to write it in the standard form. So what I was saying, this will be a very easy question because you just need to substitute the values of trigonometric ratios. Okay, and just multiply root 3 with that and you will get the standard form. So what you can do? What is cos pi by 6? Cos pi by 6 is cos 30 degree, which is root 3 by 2. What is sine pi by 6? Sine pi by 6 is sine 30 degree, that is half. Okay, and then you write z. Root 3 into root 3 by 2 will be 3 by 2, and with iota it will be root 3 by 2. And this is the standard form of complex number. Okay, so this is a very easy question. Just write the values of trigonometric ratios. Okay, and multiply whatever number is written outside the bracket, and when you will multiply you will get the standard form. Okay, so this is easy, nothing too much learn here. Okay, I will just give one question, you can tell me what is the standard form. Root 2 cos 5 pi by 4 plus iota sin pi by 4. You have to express this in standard form. Yes, anyone? Any one of you? What is the value of cos 5 pi by 4? Can anyone tell me? The value of cos 5 pi by 4.
Minus 1 upon root 2.
Yes, correct. Cos 5 pi by 4. This is 225 degree. After changing it in degrees, you can write it like this. This is 180 plus 45. And if you remember the reduction formula, it is even multiple of 90. So it will remain in cos only. And it is 180 plus third quadrant. So it will be minus. Overall value will be minus 1 by root 2. Okay. Minus of cos 45. Similarly, sine 5 pi by 4. Sine 5 pi by 4 is sine 225 degree. Sine 180 plus 45. This comes out to be minus sine 45. This is minus 1 by root 2. Now let us find the values of the complex number standard form. It is root 2 here. Cos 5 pi by 4 is minus 1 by root 2. Iota sine 5 pi by 4 is minus 1 by root 2. multiply this. Root 2 into minus 1 by root 2 is minus 1. Root 2 into minus 1 by root 2 is minus iota. This is the final answer. So now you are doing the reverse process. From the polar form, you are expressing a complex number in the standard form. Okay. So just you need to write the value. So little bit trigonometry will be used. Basic concepts or basic values or reduction formula like that. Okay. You'll be able to write it in the standard form. So basically we have completed whatever portion is there in NCRT. We have completed all the topics. Okay. Each and every topic has been covered. Yes.
So can you show the question?
Can you please repeat? I'm not able to hear you.
So can you show the question?
Yeah, sure. Just a minute. This one only? This question?
Yes, sir.
All.
Okay, sir. Thank you, sir.
All right. Okay, so I was saying that we have covered the topics which are there in NCRT, but little bit more we are going to study because there are some questions in the miscellaneous exercises where theory has not been covered in NCRT, but there are questions on the properties of modulus and conjugate. Okay, so few properties we are going to learn and then we'll solve some questions on it and that will be it. Okay, so properties of properties of see, this section is always important whenever you study properties of any algebraic portion, maybe quadratic, there are some properties of sequence and series or binomial, PNC, whatever. Okay, this section properties, it is extremely important. Okay, because mainly the chapter is dependent on these things only. Properties of modulus and conjugate. So let us write few properties first and then we'll try to understand them with the help of their application in certain questions. Okay, let us write the properties first. So it is mix. You will find properties of modulus as well as conjugate. Let us start with the first property. I will first write down these statements. Okay, then I will explain. See, in all these properties, if I am using Z, that means it is complex number, a single complex number Z. Whenever I am using Z1 and Z2, that means I am using two complex numbers. Okay, basically alphabet Z is for complex number in this chapter. Okay, so Z means only a single complex number. Z1, Z2 means two complex numbers. Z1, Z2, Z3 means three complex numbers like that. Okay, so from 1 to 4, I have written properties of conjugate, and from 5 to 7 or 8, I'll be using properties of modulus. Okay, properties of modulus. So there will be these 9 properties. Okay, let us try to understand their statements first and then we'll solve some questions and that's it. Okay, so first, second, and third. These properties can be understood in a single statement, which means that conjugate is distributed over positive, negative, multiplication, and division sign. I used a term distributed. As you can see, in the first formula, we have Z1 plus Z2 Either it can be plus or minus, because that is not a problem. If it is plus, I will write plus in the right hand side. If it is minus, I will use minus in the right hand side. Okay. Important is the property. So if basically there is a whole conjugate on the left hand side, what you can see on the right hand side? Individual conjugates. Okay. In the first formula in LHS, I have Z1 plus Z2 conjugate. And what is there on the right hand side? Z1 conjugate plus Z2 conjugate. Similarly, in the second one, Z1 Z2 conjugate is equal to Z1 conjugate into Z2 conjugate. Same is for the third one. So what happens exactly? What is happening in the first three properties? This conjugate sign, which we say bar, is actually getting distributed. It is getting distributed on all the complex numbers present there. Alright. This is property of conjugate. For example, I will take some example. Okay. Let us say I have Z1 as x1 plus iota y1 and I have Z2 as x2 plus iota y2. Okay. Let us say we have these complex numbers. Let us write Z1 plus Z2 first. So in the previous class only I told you how to add. So if you want to add these two complex numbers, so their real parts will be added, written together in imaginary part. Okay. Iota y1 plus y2. Then if I write conjugate, what is the meaning of this? What is the meaning of plus z2 conjugate? That means I am taking conjugate of this complex number. So what will happen when I will take the conjugate? This plus iota will be replaced by minus iota. Okay. Plus iota in place of plus iota, I will write minus iota. And it will come out to be x1 plus x2 minus iota y1 minus iota y2. And this will be equal to x1 minus iota y1 plus x2 minus iota y2. X1 minus iota y1 plus x2 minus iota y2. What is x1 minus iota y1? It is actually conjugate of the first complex number. What is x2 minus iota y2? It is actually conjugate of the second complex number. What have you proved? You have proved that z1 plus z2 whole conjugate is z1 conjugate plus z2 conjugate. So this is basically the proof of it. What I am saying, how to remember easily first, second and third, that conjugate is distributed over positive, negative, multiplication and division sign. That's it. First three properties are covered. Fourth one. In fourth one, there is this complex number z and there is bar two times. You know what is the meaning of bar two times? It means that conjugate has been taken two times. So it is very simple to understand that you will come back to the original complex number when you will take conjugate two times. When you are writing z bar from z, it is x minus iota y. And when you are taking conjugate once again, you will be again changing the sign of term having iota. So it will become x plus iota y, and which is actually your z only. Simple property. Okay. Can be understood easily. So if you take conjugate two times, you will come back to the complex number itself. So this was your property number 4. Now, before actually telling you how property 5 comes, and this is the most important property, maximum questions start from here only. So we'll see when we solve the questions. I want to discuss 6th and 7th property. You know, 6th and 7th property seem similar to 2nd and 3rd in case of distribution or distributive, but here symbol is different. In 2nd and 3rd, symbol distributed is bar or conjugate. In 6th and 7th, symbol distributed is modulus. What do you observe? Second is similar to 6th and third is similar to 7th. I'm not saying equal, I'm saying similar. Try to observe the pattern, okay? Second, what happened? Conjugate is distributed. Sixth, what happened? Modulus is distributed. Appearance is same, multiplication. What about third and seventh? Appearance is same, division. But in third, there is conjugate. In seventh, there is whole modulus. What is happening? Modulus is distributed, just like conjugate was distributed. So in that way, you can remember. However, there is one major difference. There is one difference. There is no similar property like first one. Okay. In modulus, there is no similar property like first one. That means do not create your own properties. Do not write like this. See, this is wrong. If you write it like this, mod of z1 plus z2 is mod z1 plus mod z2, then it is wrong. It happens only in special cases, not always. So it is not any property. That is why I'm not written it here. Okay. Z1 plus Z2 modulus is not equal to mod Z1 plus mod Z2 always. That is why it is not a formula. So 6th, 7th, 2nd, 3rd can be understood like this. Now remaining three properties, 5th one, 8th one and 9th one, that I will explain. 5th one is easy. 5th one is easy. To understand this, I will take a complex number Z as A plus iota B. Okay. If this is Z, what about Z bar? Z bar is A minus iota B. You should remember that how we write conjugate. And what is mod Z? Mod Z is under root A square plus B square. Now based on this, I can easily show that Z bar is mod Z square. How? Multiply Z and Z bar. That means A plus iota B into A minus iota B. You will multiply this, you will get A square minus iota B whole square. This is A square minus iota square B square. Iota square is minus 1, so this will become plus. What is A square plus B square? Mod Z square. What is the meaning of this? Z bar is mod Z square. This is your property number 5. Okay. What is the meaning of this? The meaning of the property is that if you multiply any complex number by its conjugate, you will get the square of its amplitude. You can learn it in that way. Okay. Otherwise, simply remember Z into Z bar is equal to mod Z square. This property is very important. 5th one. Maximum questions start by the application of this property. Okay. So when we'll solve the questions at that time, we will take care about it, that this property is important and how we start the questions by the use of this property. Finally, 8th one is easy. 8th one, you start by writing Z. So let us suppose that Z is A plus iota B. Suppose if this is Z, what is minus Z? Minus Z is minus A minus iota B. Okay. You multiply both sides by minus 1, you will get minus Z. What is Z bar? Z bar is A minus iota B. Okay. We change the sign of term having iota. What is minus Z bar? Minus Z bar. It is minus A plus iota B. Okay. So we have the values of Z minus Z, Z bar minus Z bar. Now what is the property? If we come back to the property, their modulus are same. Their modulus are same, which is obviously true. What is Z? Mod Z under root A square plus B square. How you will write minus mod of minus Z? Minus A whole square plus minus B whole square. This again will be equal to root A square plus B square. How you will write mod of Z bar? This will also be same, A square plus or minus B square. So all the values will come out to be same. All of them will come out to be equal to under root A square plus B square. That is why. Alright. All of them. Mod Z minus Z mod, Z bar mod and minus of Z bar mod. All of them are same and all of them are equal to under root A square plus B square. This is the result. Finally, ninth property. Ninth property I'll explain and then we will solve some questions. Okay. Ninth property. See what is the property? This is very important property. Okay, good one. If we have any complex number and we have to take its power n times and then we take its modulus, which is your left hand side, it is equivalent to that I first take the modulus and then take the power n. What is the meaning? Ninth proof. I will start with this. Mod of z to the power n. Z to the power n means z is getting multiplied itself n times. Z is getting multiplied itself n times, right? And using the distributive property. What I said, modulus is distributed in product sign. So this z is getting multiplied itself n times. So what will happen? Mod z will come n times, right? And mod z into mod z into mod z n times will be equal to how much? Mod z to the power n. So what is the proof? Proof is of one line. And what is that? That we have to take the modulus of every number, and how we can do it using the distributive property of modulus. I hope you might have understood this. So quickly just go through the properties. First, second, third. Conjugate is getting distributed. Fourth one, take conjugate 2 times, you will get the complex number. Sixth and seventh, they are properties of modulus but similar to second and third. Eighth property, modulus of z minus z, z bar and minus z bar all are same. Fifth property, z into z bar is mod z square. And finally this ninth property, z to the power n mod is mod z to the power n. Based on this, we are going to solve some questions now. Okay. All right, so I'm starting with the first question here. Question number 1. Just confirm for one time, please. Am I audible to everyone? Can you hear me?
Yes,
Yes,
sir.
sir.
All right, all right. So here is the first question. Solve using properties. All right. Solve using properties. If z is root 3 plus iota to the power 5, then mod z equals how much? This is the question. Let me see if you can answer it quickly. You have to find modulus of z, and z is this complex number. Solve it.
Sir, 32.
Sir, is the answer
Sir,
32?
32. Sir, excuse me, sir.
Yes, anyone?
Sir, is the answer 32?
Please repeat once more. The answer is
Sir,
32.
30.
32. 32 is correct. Yes, yes, 32 is correct. Can you tell me how you have done? What was your step?
Last property.
Yes, good. See, mod z means that basically we want to find value of this expression. All right. We want value of this expression under root of root 3 plus iota to the power 5. And now let us come back to the property. This one only, right? Ninth one. See, this is exactly similar to this expression. Z to the power n modulus root 3 plus iota to the power 5 modulus. This will come out to be under root of, sorry, modulus of root 3 plus iota, and this power 5 will come outside. Now what about the modulus of root 3 plus iota? For this we have the formula. Modulus of root 3 plus iota means under root of a square plus b square whole power 5. This is root 4. Root 4 is 2 to the power 5. Answer is 32. In this way you have to solve it. Okay. Good. Correct approach. Let us solve another question. if mod of Z1, mod of Z2, mod of Z3, and mod
Sir,
of
can you
Z.
scroll up a little?
Yes, yeah, sure.
Done, sir. Thank you, sir.
All right. Second question. This is a very good question. Okay, important one. All right, try this. Mod of Z1 equals mod of Z2 equals mod of Z3 equals mod of Z1 plus Z2 plus Z3. All of them are equal to 1. Based on this, you have to find the value of this modulus.
So can you scroll up slightly?
Yes, sir. Yes, can anyone tell the answer? See, it is a good question. Let me help you. Understand, try to understand the explanation. We will start with this first result that mod Z1 is 1. Sorry. Mod Z1 is 1. Whatever I will be doing in this particular part, exactly same way I will be proceeding in others as well. What is the first step? Square both sides. Square both sides. Okay. And as I was discussing, when I was telling you the proofs of the properties, I said that fifth property is very important. So square of this mod can be rewritten as Z1 into Z1 bar. Why? The property used is fifth one, Z bar is mod Z square. Alright, this one. And on the basis of this, if I shift Z1 to the right hand side, I can write Z1 bar as 1 by Z1. Now use this, repeat this process in mod z2 is equal to 1 as well as mod z3 is equal to 1. This is one, square both sides, use the property, write z2 bar as 1 by z2. Alright, similarly, now you need not to write it every time. Similarly, z3 bar is 1 by z3 because its modulus is also equal to 1. Now mod of 1 by z1 plus 1 by z2 plus 1 by z3 equals. This can be written as 1 by z1. In place of 1 by z1, I can write z1 bar. In place of 1 by z2, I can write z2 bar. In place of 1 by z3, I can write z3 bar. Why? I have just proved these results. That is why. Now, till now, I have used property 5 three times. That is z bar is mod z square. And on the basis of that, I have changed this expression in the question to this one. Mod of z1 bar plus z2 bar plus z3 bar. Now, kindly note this property. How I have written it like this, using the distributive property of conjugate. If I have z1 plus z2 bar, I can write z1 bar plus z2 bar, right? If I have z1 plus z2 plus z3 bar, I told you this conjugate is distributed over positive, negative, multiplication, division. So I am writing it in the reverse order. That is mod of z1 plus z2 plus z3 conjugate. Okay, this property. Finally, eighth property, second last property, and I'll be able to write this as mod of z1 plus z2 plus z3. Why? Because the property used is mod z bar equals mod z. That means modulus of a complex number and modulus of its conjugate both are same. So that is why modulus of z1 plus z2 plus z3 or modulus of conjugate of z1 plus z2 plus z3 both will be same using property 8. You can write these properties in the bracket. You can write it here since mod z is equal to mod of z bar. And now the answer is 1. The answer of our question is 1. Why? Because the value of this modulus is also given in the question. See this. I haven't used this result till now. Why? Because this is our answer. The expression asked in the question changes to mod of z1 plus z2 plus z3 and its value is given 1 in the question itself. Alright. Totally property based question, very important. These questions are asked in JEE mains and advanced. Okay. So when we will study this chapter till JEE main level or advanced level, you will go through these questions a lot. Okay. Important one. Anyone having any doubt in this question? In the explanation, any doubt?
No, sir.
All right, good.
So can you explain the first part again?
Which one? The initial part of the question?
Yes, sir.
See, in the question it is given that mod z1 is 1, right? So mod z1 is 1, but you can't simply open mod like that. Okay. To get rid of modulus, you will have to use property 5, and in property 5 it is square of the modulus. So that is why I squared this first. Then I have used the property that mod of z square is z bar. Alright. So mod of z1 square is z1 bar. This is 1. And from here I am taking z1 to the right hand side, so it is in multiplication, it will go in the division. So in the expression, see in the expression I have 1 by z1. Here in place of 1 by z1 I can write z1 bar. Similarly, proceeding in the same way, 1 by z2 can be written as z2 bar and next one can be written as z3 bar. So based on that, I have reduced this expression to z1 bar plus z2 bar plus z3 bar modulus. Then using the distributive property, and after that using the property that mod z is mod z bar, we were able to get its answer also as 1. Why? Because the property of value of this expression mod of z1 plus z2 plus z3, this is also given equal to 1. This is the explanation. So 2 3 properties are used in the same question. See, if you follow any textbook apart from NCRT for your school exams, okay, you might find some such questions like
So we can't hear you. So your screen is also stuck.
am I audible to you?
So
Yes,
yes,
sir.
you're audible.
Yeah, I got disconnected, but am I audible to you now? Screen visible?
Yes, sir.
All right.
So screen is not yet visible for me.
What about others?
Visible, sir.
All right. There may be a lag. You can wait. Otherwise, also I'm writing the next question because this I have already explained 2 times. This is the next question. X plus iota y. Okay. We solved such type of question in previous class. But today, I think it was the same question. But today I want to solve it using properties. All right. X plus iota y. This is equals a plus iota b upon a minus iota b. And we have to prove that x square plus y square is equal to 1. Try this question. Using properties, I'm repeating. Can anyone give any idea about how to use the properties or how we should proceed in this question?
So you can take x plus iy as z1.
Yeah, that is okay. Then what about next? What to do after that?
So, and a plus ib will be z2,
All right.
and the
And let's say
denominator.
minus item is Z3. Yes. What after that? What do you want to do after that?
So denominator will be conjugate of z2,
Okay, fine.
and then you use the property.
Which one? That is what I'm asking.
So the fifth property.
Okay, you want to use fifth property. All right. All right. So you are coming to the property. What I can do, instead of assuming anything like Z1, Z2, Z3, I can straight away proceed by taking modulus both sides. Taking modulus both sides. All right. Let's do it this way. So I'm taking modulus both sides, right? Now, what you will get on the left hand side, you know what is the modulus? So when you can take the modulus, see if two complex numbers are same, what is the concept behind it? Taking modulus means if two complex numbers are same, obviously their modulus will be same, right? If two complex numbers are same, that means points are same, coordinates are same, so distances from origin will be same. That is the meaning of taking modulus both sides. What is the formula? Under root of square of real part plus square of imaginary part. What you will use on the right hand side? In the right hand side, you will use the distributive property. Right hand side, you will be using the distributive property. Which property? Which property? Z1 by Z2. Modulus is mod Z1 by mod Z2. This property, right? So what will happen? Under root of x square plus y square is under root of a square plus b square. You know what is the formula, how to use it, and it is under root a square plus b square. So question is over because root of x square plus y square is equal to 1, and that's why if you square both sides, the answer will be 1. That's it. Okay. Try to use the properties. Try to use those results. Anyone having any doubt?
No, sir.
All right. So I'm taking the last question, and that will end the chapter as well as the class. Okay. Revise the chapter, and important is you solve the questions from your textbook. Okay. Because when school exams come, you should be well prepared before the time. Okay. That is why I'm taking your school topics, or I'm covering the topics for your school exam first, and then we will continue with our preparation. All right. So now it's your duty to solve the questions from your concerned textbooks. If you have any doubt, you can WhatsApp me. I will tell you the doubt there. Okay. No problem with that. Okay. Last question. If Z1 and Z2 are complex numbers, if Z1 and Z2 are complex numbers such that mod Z2 is 2, sorry, mod Z1 is 1, then find value of Z1 minus Z2 upon 1 minus Z1 Z2 bar modulus. This is the last question. Z1 Z2 are any two complex numbers. Modulus of Z2 is 1. Based on that, and nothing is given about the modulus of Z1. Okay. And based on that, you have to find the value of this expression. There is modulus. In the numerator, it is Z1 minus Z2. In the denominator, it is 1 minus Z1 Z2 bar. Okay, I will have to help you in this question. It's a little bit tricky. First thing, mod of Z2 is 1. This is something related to your second question. Mod of Z2 is 1. Square both sides. Okay, squaring both sides. This come out to be Z2. Z2 bar is 1. Remember fifth property, property 5. Okay, property 5. Now In place of Z2 bar, I can write 1 by Z2. Similar type of working was there in second question. Now what we will do? In the question, in place of Z2 bar, I will write 1 by Z2. Okay. Z1 minus Z2. In the denominator, I will take the LCM Z2 minus Z1 by Z2. Okay. What you can observe? First, you take Z2 in the numerator, and this is Z2 minus Z1. So, if you take minus common from the numerator, you will get Z2 minus Z1 here, and the denominator also you get Z2 minus Z1. Finally, it is left with minus Z2. And if you remember the eighth property, in eighth property, mod of Z, mod of minus Z, all of them are same. So from here, I will use this property, and in place of minus Z2 modulus, I will write equal to mod of Z2. And what is its value? Its value is 1. It is given in the question itself. So ultimately, once again, it is the use of the question. Value given in the question, and property 5. Mod Z2 is 1. Square it. Use the property 5. Write Z2 bar as 1 by Z2 and put its value here in the question. When you will do it, then you will put Z2 bar as 1 by Z2 and you will take the LCM and everything. Finally, after taking minus common from the numerator and denominator gets cancelled and only minus Z2 is remaining. Then you will use property 8, and with the help of property 8, you can write it equal to mod Z2 and its value is equal to 1, which is given in the question. This question was asked in IIT Advanced, but many years back. Okay, but question is from IIT entrance. But ultimately, it is use of these 8 to 9 properties, and you can solve any question based on these. Okay, so now try to solve some questions based on these properties from your textbook. That will be very helpful for you. Otherwise, chapter is over. Okay, now what you can do, see, before we end our class, now our class will be next week. So in NCRT, there are these exercises. You have to complete all of them, including miscellaneous. This is the homework. Your class may be on Monday or Tuesday, whatever. Exercises are not very big. Okay, they hardly have 5 to 6 questions in every exercise. So 2-3 exercises are there and one miscellaneous is there. You have to complete all of them. I'll be discussing the questions first, your doubts first, and then we will start the next chapter. It may be sets or it may be straight line. All right. That's it for today. Thank you very much. Thank you, sir.
Thank you, sir.
Thank you, sir.
Excuse me, sir.
You want to ask something?
So when are we going to do the rest of the PNC because it's not
Yeah, we'll be
completed?
completing it. We'll be completing. Actually, what I am trying to do, I am trying to complete some of your school topics first.